Hi again, students. How are we doing? Level 2s again. This is for you. So I'm going to go through obviously the chassis technology module, and I'm just going to go through a few presentations that I've got, give you some advice on how to tackle the chassis technology phase test. For those of you that have handed me your retakes on LVO1 servicing, that is in the process of being marked, and that will be sent out to you by the end of next week. So what I'm trying to do is just obviously mark it, get it sent out back to you, and then if you've referred or failed the test, getting it back and then going from there. Okay, so let's have a look at this. So steering systems is obviously, we went on from geometry last time, and obviously the objective last time was just to give you a bit of a recap on the geometry of the steering system, because we've done quite a lot of work on that in the classroom anyway. So what I'm going to do is I'm going to go through this. I'm going to present it on the slideshow and we'll just go through it. Now, some of this you may have already seen. So for instance, reasons for steering, okay? I'll put this slide on Moodle as well for you. I think it is already actually there. So you can have a look at this for your own perusal, okay? So the purpose of the steering system is obviously to enable the driver to control the direction of the vehicle. Obviously we look to turn the wheels in a direction, and we would hope that when we turn the wheels, the steering would feel light, but we'd achieve a positive steering feel coming through the steering wheel so we can actually feel what the tyres and wheels are doing. If we look at Atkins Principle, we spoke about that yesterday. I'm not going to go through that again. Tracking went through yesterday. Okay, so I spoke to you before I left about steering boxes. There are three main types of steering box. That's the cam and peg. Okay, that's the recirculating ball box and the worm and roller box, and that's what we're looking at here. We're looking at a type of steering box. You probably won't find these on modern cars. In fact, you won't find these on modern cars. They're not used anymore. They were used a long time ago. The reason for that is, well, they're clunky. There's a lot of free play, and they're quite a complicated design. Often went wrong. We've replaced that with a much simpler design, i.e. the rack and pinion. But let's take a little look inside there. So if we have a look inside, what you can see is the recirculating ball on the right and the cam and peg on the left. And I think the way I described this to you was, if you were to take a screw and you were to put it into a piece of wood, the motion of clockwise turning would cause the screw thread to force the screw to go into the piece of wood. If you kept the screw stationary and you allowed the piece of wood to move and you put the screw in action to the screw, obviously the wood would then move left and right. And this is what we're looking at, or back and forth, and this is what we're looking at with this steering box design. We're looking at a system where we effectively rotate a shaft, and that rotation transfers to a helical, which then transfers to a linear motion left and right, which through drop arms and through linkages then transfers to the wheel hubs, and obviously we turn the wheels left and right. The problem with these systems, like I say, a lot of free play. If you look at every single part of it, there are so many parts that have mechanical linkages, and every mechanical linkage offers some form of free play. So this has been superseded and by the rack and pinion, and obviously as well the measurement side of things, you can see how big it is. Takes up a lot of room. Modern vehicles and modern engines, no way you're getting that in the engine bay. Okay, so with that has been replaced. What has been replaced by is the rack and pinion steering system, and you're looking at the steering wheel at the top. Remember, the steering wheel adds an advantage, a mechanical advantage for the driver. It allows us to turn the steering shaft, but it also amplifies the effort we put into it. Remember, force times distance equals the amount of torque we can put into that. And then the shaft goes down, and we've got a universal joint which can change its angle, because remember, we're going to want it to go down after it goes through the bulkhead. And then it goes into the rack and pinion type system, which is effectively just a wheel, a pinion, a gear, and a rack, which then allows the pinion to spin. The rack can move left and right. Main advantages of this, obviously, direct acting, takes up less space, and it's a simpler operation. So that's what we're looking at, a rack and pinion design. On the right is a sort of a better diagram, I think, to describe the rack and pinion. And you can clearly see the situation of the pinion locking in to the rack. Okay, and then obviously if we spin that pinion, the rack's going to move in a linear motion left and right, and that's going to obviously act on the rear of the hubs, and that's then going to transfer to the steer wheel, and the wheel's then going to go left or it's going to go right. Obviously we've got track rod arms and track rod ends, or tie rod arms and tie rod ends. Obviously the Americans use tie rod, we use track rod, and you've got ball joints at the end of that. The ball joints are obviously there to allow 360-degree movement, whilst also allowing us to obviously bolt that system to the hub. When you look at a power-assisted steering system, we're looking at exactly the same mechanical system, give or take, but we're introducing a hydraulic system on top. So this is hydraulic power-assisted steering. Now, the reasons why we might want power-assisted steering are because we are parking the car, we're maneuvering the vehicle, we're articulating the vehicle at low speeds. Now at low speeds, obviously we need to turn the steering wheel quite far to the left or quite far to the right, depending on which way we're going. The assistance of the hydraulic fluid allows us to do this very, very smoothly and easily. Because what's basically happening is we're relying on a pump, normally a sliding vane type pump, which is powered by the engine. And that then has obviously a fluid which it pressurizes. That pressurized fluid can then be directed via the control valve or rotary valve in the rack to go one side or the other side of the rack, depending on where we need it to move. So if you imagine we need it to move to the left, what we'd want to do is put the pressure to the right. So the pressure builds behind it. Then it forces the piston, which also is connected to the rack, which forces the rack and assists your steered effort. If we go the other way, all that happens is we redirect the fluid in the other direction. When we're checking these kind of systems, I mean, you're talking about 1990s vehicles really. All modern vehicles in the last 10 years would have electric steering. But in the 1990s, you're working on an old Polo or something and you want to check this system. Really what you're looking for is you're looking to get it on a level surface. You're looking to turn the steering wheel from left to right with the weight of the vehicle on the actual steered wheels. And you're listening for any clunks, listening for any whining, any sort of noises that don't sound quite right. I must say, when you put it on the furthest position, it is going to make a little noise because it's under the most amount of pressure at this point. The pump's probably working at its hardest, and we're trying to put the most amount of fluid into that side of the rack. Therefore, it's going to make a little bit of noise. But when these systems go, you tend to find the steering's really heavy and you get a lot of horrible noises coming from the steering system. If the steering was heavy, I think the first fundamental check would have to be the belt. Obviously, this is a pump that's powered by a belt, powered by the crankshaft. We would have to make sure that belt was intact. Probably the most likely thing to go is the belt. Second from that would be the pump. We'd be looking at the pump, obviously, after looking at the fluid level. If the fluid level was low, for sure, we're going to lose a bit of pressure there. So we'd need to look at that. Obviously, if we run the system low for any long period of time, we're going to be probably running the pump dry, and therefore the pump's going to go as well. So if you're diagnosing this system, you're looking at the belt, you're looking at the pump, and you're looking at the fluid level. After that, we've obviously got to start thinking about potential of the rack being at fault. Other things that can happen with this, obviously we can get leaks because obviously you've got the lines there, okay, that allow the hydraulic fluid to go into the rack and they can burst. In your phase test, you're going to have to draw this. You're going to have to draw a power-assisted steering system and label the parts of it. This will do the job. That is all you'll need to do. Okay, so we've got the track rod end here. So again, I'm just giving you an overview of every part that you should really know by now anyway. Track rod end obviously is the part that most likely needs to be replaced. Okay, if we're checking this, we're going to check in the steering system. We're looking at putting our hands on a 3 o'clock position and a 9 o'clock position, and we're looking at using our shoulders and our hips to rock that wheel left and right, and looking to hear that that kind of free play and that then knocking of the ball on the joint of the track rod end. And if we look at that, If it has got play, obviously it's going to make a knocking sound. If it makes a knocking sound, we need to replace it. Also, we need to look at the boot indicator. If the boot indicator is split, we obviously need to replace that. It's only a matter of time before the grease comes out of the joint. The joint runs dry, friction, heat, damage, wear, and then you've got free plate and you've got the potential of it obviously knocking again. If it gets really severe, could cause it to obviously completely shatter, completely destroy itself. Then you have got problems because obviously the vehicle can't be steered. Tracking, we've been over that, and I'd like you to research how to do tracking, and I'll put that to you on Moodle. And then just one component, so we can see on the right here that that's a ball joint where the gator has split. The grease has obviously come out of the gator, and that would obviously need to be replaced. And you've got worn bushes here as well, which can be caused by a number of things. Mostly it's just because of the amount of force they have to withstand when the vehicle's moving, even in a straight ahead direction. They're under immense amounts of stress and strain, and obviously over time that is going to degrade the rubber. Also, naturally, rubber is going to perish, so the rubber can perish just through natural situations, the salts, the water that are underneath the car there. And obviously, if we're looking at any damage, we're looking at the tyres. There could be tyre wear that indicates what kind of damage we've got. In my next video, I'll look to cover a little bit more on power-assisted steering. I'll look to cover a little bit more on the steered systems, a little bit more technical details. Okay, thank you.